Good afternoon, ladies and gentlemen. It's an honor for me to speak at the 12th Conferencia Española Pasifos in Spain. My topic is For Schools Applies Energy in More Dimensions. First, I will explain and present a school in Basweiler. It's a small city near Aachen in Northern Westphalia in Germany. It's a grammar school. And the second are some slides from an actual, also very ambitious project in a small municipality. What did we, before we started the design for the renovation and retrofit of the school, of the grammar school in Basweiler? First, we checked for construction defects because the city government ordered us to research projects and to analyze projects for optimizing their energy efficiency. But we did not intend to renovate buildings which didn't have construction defects or which did have only very few construction defects. And this grammar school, there were a lot of construction defects, so it should be renovated. And by doing that, we could also optimize the energy efficiency of the building in an economic way concurrently. We also analyzed the U values of the different buildings. We also analyzed the energy heating requirements, the energy for cooling also. And the result was that we recommend that the municipality and the mayor to do the first project as a grammar school because it was very economic. We checked how many investment costs had to be invested to save 1 kilowatt hours from the first day. And the fewest investment costs were by this grammar school. It were 1.42 euros for saving 1 kilowatt hour from the first day, 1.42 euros per square meter. And to compare that with energy saving costs, we also analyzed that. To save 1 euro energy cost from the first day, they had to invest 20.68 euros per square meter. Compared to other buildings, the most investment would have been in the case of a school in another part of the city that were 131 euros. And what had we to do? It was very important optimizing the exterior walls, thermal insulation in the case of the curtain wall. Also, we should take care for the building aesthetics. Architects do not want to change the building's aesthetic if it's good, only for energy saving. And we also to think about special difficulties, problems which had to be solved. And I imagine high quality in aesthetics does not eliminate aesthetically optimized facades regarding their energy efficiency. There were 5 construction phases in that school. We had the classrooms, the building for classrooms, and the canteen. We extended also the auditorium for using it also as canteen. The first construction phase was the administration building. The second, the teaching rooms for particular subjects, e.g. physics and so on. And the last was the gym. This slide shows us the building with the classrooms and the auditorium before we started the construction phase. This was a concrete building from the 70s. We did not only renovate and retrofit the facades of the building, we also modernized the school in total. So the sanitary rooms were renewed, a teaching room for self-teaching was installed, and some other equipment to make it to bring it to a modern school. For the first construction phase, after finishing the first construction phase, the major asked me to prepare a participation for a competition, for a German-wide competition, because the facade which we realized was a HPL facade. That's high pressure laminate. It's nothing other than recycled paper, and the plates were in different sizes and different colors. So it was possible, or it is possible in the future, to renew panels without it being noticed if necessary. The government of North Rhine-Westphalia, they evaluated that project as the best in competition in North Rhine-Westphalia, and so the city got a grant, a state grant of around 4.8 million euros, because it was the best project in that situation. And North Rhine-Westphalia intended to have that project in their country. Because of that, they spent such a great grant. For me, it's always important to have a neat and tidy construction site. Passivhaus is not a high-tech building. Passivhaus is very easy to realize, but it's obligate to work neat and tidy. And before we start the construction of the building, we always organize and perform workshops for the crafts for all involved companies to sensitize and to motivate them to work neat and tidy and to realize a building in a very, very high quality. The result of this grant and the competition was that the investment cost for passive standard in total was around 10 million euros. The investment cost of a building compared to NF. NF is the energy requirement by law in Germany. And at that time, it would have been cost 9.6 million euros instead of 10 million euros, only 400,000 euros less, but without the state grant. In that case, they got a state grant of 4.83 million, so the client's equity ratio was only 5.26 million euros. It was a very good business for the client. To the technical efforts, we installed the airtightness layer outside of the exterior walls, because in the case of an existing building, it's very complicated to make it airtight, because we do not know how did they handle in the past the installation ducts, for example. Are they airtight or aren't they? And so to make the tightness to ensure the tightness, we decided for an outside airtight surface. Here, this slide shows us the airtight foil. There were a lot of leakages, and we had to fix and to close all the leakages very, very carefully. Otherwise, we would not have been past the blower door test at the end of the realization of the construction. This slide is a proof for the very careful, neat and tidy work of the craft. And this slide proves that they were very motivated and sensitized. For fixing the curtain wall, we decided for steel angles, for stainless steel, because stainless steel is a better lambda value, and so by doing that we could reduce and minimize the thermal bridges. It was also important and to note all connections. And here we see also an airtight connection between the roof and the outside wall. And this slide is also a proof for the very carefully and clean and proper work of the crafts. Here you can see dirt. It's always clean, and it's very, very important for me in all cases of buildings, not only in the case of a passive house. The facade is a ventilated facade because of avoiding damages by physical aspects, and so we decided for ventilated facade. The thermal insulation, we had also to protect it against rain, and so we covered the thermal insulation with a bituminous foil or a facade sheeting. Also, this slide explained the neat and tidy and also the carefully work which the crafts did in that case. There were a lot of leckages. I also talked about that. And you can also see the steel angles from stainless steel and some panels of minor wool for the appendixed thermal insulation of the outside wall. So it is obligate to separate the bearing construction by thermal separating materials like plastics or foam glass and so on. Also materials with a low lambda value. During the construction phases, we had to cover and to close the window areas because we changed the windows. All the windows, it's obligate to use triple glazed windows in the case of passive houses. The thermal isolation was installed into three layers, and we always covered the connections of the of each layer and plates of minor wool to avoid thermal bridging. So the next slide shows us also an exterior airtight envelope, and here you can see how carefully there's no leakage. It's very perfect installed. We had also some parts of the building to save back the ceiling, the concrete ceiling, and to fill out it with thermal insulation to avoid thermal bridges. That was one of the most ambitious challenges to avoid thermal bridges in the case of that building. Sorry. But we had also some faulty constructions when we made control of the thermal insulation. Is it perfect installed, or are there thermal insulation missing? So we found faulty constructions, and the company had to correct these mistakes. For the facade, for the curtain wall, we used also stainless steel materials for the supporting structure. Also, the ceilings of the basement were insulated, so we could guarantee a completely thermal insulated building. Around 50 centimeters thermal insulation were added of the basement walls in the vertical connection, in the vertical direction, because of minimizing. It's not possible to avoid thermal bridges in total there, but we could minimize the thermal insulations by doing that. The installation ducts are also a challenge in the case of existing buildings. because you install the installation pipes, you have to plaster the ducts, the shafts, because in the case of a massive building, always the plaster is the airtight layer. And together with the client and the teachers, we decided for open ventilation pipes. So the pupils could gain experience, and they could always see that they use a school, which is a Passivhaus school, with permanently fresh air supply. And we had also to use materials for sound absorbing. On the left, you can see a classroom before starting the construction phase, and the right is under construction, and the next is the building after finishing the construction. And the yellow material, what you can see, shows us very nice that we extended the window areas at the south. The beam construction, we keep the beam construction, and for each building in which are classrooms, we change the color. So the pupils can identify from the outside with their classroom or with their classroom building. A part of pupils were educated in the yellow, another one in green, red, and so on. Some pictures after finishing the construction. Here we can see the open pipes. In the case of open pipes, it's necessary to use double pipes because otherwise the first room would be supplied by warm air in the winter time, and the last room the warmness wouldn't reach the last room. So we must use double pipes which are insulated inside. The floors and the corridors, there we reduced on the north the window areas by 90%. Otherwise, we would not have reached such a very, very good energy efficiency of the building. But for corridors, it's enough daylight. It's not necessary to have very, very great big window areas. This is a part of the PHPP. That's an Excel tool to calculate, is it a Passivhaus, yes or no? And the result for the building section 3 and 4 was 14 kilowatt hours per square meter per year for heating energy requirement. And so we could say, yes, it's a Passivhaus. And the blower door was 0.6. In that construction phase, the building section 3 and 4, the existing building at the auditorium in the center of the building, and we expanded that area, and so they use it also for canteen, because it's a school in which the pupils were educated also in the afternoon. That's the gym. The gym was the last construction phase. Complicated was the oscillating bottom. We did not insulate that bottom. We waived to do it because that construction was very, very new. It was renewed only 1 year before. And for me, it's not sustainable to make waste from material which works very well and which will work very well within years. The result of the gym was 15 kilowatt hours per square meter per year. It was also certified as a passive house. If one of the building sections would not have reached certified passive house standard, the municipality had to give back the 4.8 million grant. So it was a huge challenge for us to reach that goal. Here we can see a detail of the building, of the administration building. That was before the construction phase, and that is after. Here you can see what I told before, the beam construction behind the extended windows at the south side. And here we have the so-called yellow building. And the plates have different sizes, different Greek colors, so you can change. In the case of school, it could be happen that it would be necessary to change from time to time some plates, but so it looks always new. And the material for the facade, I remember, sorry, it is high pressure laminate materials, high pressure laminate panels from recycled paper. For me, it's very important to take care not only for energy efficiency of a passive house. We should also use recyclable materials. We should avoid hazardous waste. We should think about intelligent water management and other ecological aspects. We should avoid materials which are toxical. In a lot of cases, we have passive houses with insulation materials, with toxical materials like hexabrom cyclododecan. It's a material which is very dangerous in the case of cancer. This slide is self-explained. Here is the auditorium and the canteen. Also the canteen before and after. Also the outside view of the auditorium and the canteen. Compared to the energy requirement before the building construction, the energy requirement for the administration building was 220 kilowatt hours per square meter and year. Afterwards, 15. So the energy saving is exactly 93.2%. And it's not only calculated, it was a measured value during monitoring, which we did after finishing the construction. In November 2010, when we realized the first construction phase, immediately after finishing the first phase, they won a German-wide competition, which was called Municipal Climate Protection, and they got a prize money of 40,000 euros. It was a very ambitious, and for us, it was a very, very successful project. The result of the monitoring was that in any cases of, outside temperatures, the inside inside temperatures were always the same, always around 22 degrees, independent from the outside temperatures. What about the CO2 concentration in the classrooms? In Bavaria, some time ago, they made a measurement in a lot of schools to measure the CO2 concentration. In Germany, it should be maximally 1000 ppm. And only in the case of Bavaria, in that analyzing project, more than 50% of schools had a CO2 concentration of more than 1,600,000 ppm. Only in the case of 17%, they had less than 1000 ppm. And in the case of our school in Basweiler, we had mostly only 400 ppm, only 400. It's a very, very successful value. Only in one case, there was a concentration of 800 ppm, but that was the result of double occupancy of the classrooms, because we did the construction during operation. And so it was necessary from time to time to bring pupils from two classrooms in one classroom. It's clear that then the CO2 concentration would be the double. But 800 for the double is also a very, very good result. And now I come to the end and will present some slides of another very ambitious project. The mayor of Basweiler, of this grammar school, which I presented just, recommended us to the mayor of another municipality, and they also ordered us to renovate and to modernize their school, the school center in the municipality of Titz. Here is a building under construction, the thermal insulation, and you can see that we decided for wooden material, because wooden material is a regrowing material, a renewable material. I imagine that we should also use renewable, regrowing materials for our buildings, and also we should use recyclable materials. You can here compare the building aesthetics before the building construction and afterwards. And for the colors, also for the colors of the facade and also the window frames, and also inside, we use the logo colors of the municipality. That was what they want. The client asked us sometimes, is it possible also to work with the logo of our city, with the logo colors of our city? And we tried and did, and I think it fits. Also with the chairs, with the tables, and here for the gym, we used also wooden facade. We decided for wooden facade, and we had inner courtyards to bring enough daylight in the corridors, also by using and by ensure enough daylight supply. It's a way to save energy, because for electric lights I have to use energy. And, so it's also important to reduce the CO2 concentration in schools. For me, it should be, in my opinion, it should be obligate to build new schools, and also in the case of complete renovations of buildings, of school buildings, it should be obligate to do it in Passivhaus standard, because it's an advantage for the health of the pupils and the teachers, and it's also an effort in support for supporting rooms and the classrooms. We have to supply the classrooms permanently with fresh air and to reduce the CO2 concentration, so we can guarantee better learning, better teaching, and the pupils will not become tired so quickly, or they do not become headache. And that's why I say in schools, for schools applies efficiency in more dimensions. There's a, let me finish please with Swedish wisdom. A child has 3 teachers. The first teacher are the other children. The second teacher is the teacher himself. And the third teacher is the classroom. Muchas gracias.